Hello everyone, welcome to the new episode of the Utility Cloud Guide series. In this video podcast series by Binary, we invite industry experts to talk about trending topics and share knowledge with the utility community. I am Umang, your host for the day. Today, the expert thought on which we'll be talking about is water is technology. To throw the light on the topic, today on the show, we have Jim Lauria. He is the Vice President of Sales and Marketing at Mazzei Injector Company, a designer and manufacturer of innovative contacting and mixing technologies for a wide range of water treatment applications. He has traveled the world benchmarking and documenting the best global water management practices. He is an expert writer in the water industry also. As a writer, Jim has published feature and cover articles for most of the leading water industry publication in the US, as well as many top international magazines. So with this vast experience in the water industry, we will discuss with Jim how water and technology is related. So without further ado, let's welcome Jim. Hi, Jim.
Hi, Umang. Thanks so much. I really appreciate the opportunity to conduct this interview with you. Thanks again.
I appreciate Jim for giving us the time and coming on this podcast series. So Jim, when I heard this line, water is technology, I was excited to hear more about it. I'm sure our audience is equally interested. So can you please let me know or let us know what is in your mind when you say this particular line?
Sure. So water is technology. I just posted this and published it on LinkedIn and Water Online. And it's in a series of what I've been writing about the connection between water and everything we hold dear. And I wanted to talk about how people should recognize that water is technology, that technology needs water and water needs technology. And so that connection for both sides is why I published the piece just yesterday.
Yes. So I totally agree with you, Jim. Thank you for sharing the thoughts. My next question would be on the similar line. How does technology need water?
Sure. So if you look at technology and the way it works, just the systems, the computers, the hardware, the equipment that we use, it's mostly mined products. It's the copper, the wiring, the silicon chips. They all require a lot of water. In my previous life, I was CEO of a mining company, so I know firsthand how much water it takes to mine different types of minerals and metals. If you look at copper, the largest producer of copper is Chile. And up in the Atacama Desert, which is one of the driest places in the world, you need a lot of water for the beneficiation, separating the ore from the metal. You need it in a refining process. You need it at the actual mines. So water is a key operating component for any type of mining. You talk about glass, any plastics, you're talking about oil, which again requires a lot of water. So in terms of that, there's a lot of water involved. Now, also in terms of, if you look at server farms, right, you're moving a lot of electrons when you use your iPhone, your Samsung, whatever type of phone you're using, you're tweeting, you're using LinkedIn, that's moving electrons. And these server farms get pretty hot when they're doing that. So they need cooling water. And it's becoming a big issue. Cooling water in server farms, if it's once passed through, you're taking that heat and you're taking a lot of water, and then you're putting that water back into the environment or passing it along to a water treatment facility with a high degree of temperature in it. A lot of water used in technology.
Yes, I agree with you, and that was very fascinating. But with these thoughts, Jim, I can stop myself to ask the next question, and that is, how does water need technology? As we rightly said earlier, that these are interrelated things. So, what do you think?
Yeah,
So, how does water need technology?
Yeah, sure. So if you look at, I like to look at a water treatment system like the human body. And so you've got the circulatory systems, the pumps, the piping that's able to move water around, and the pumps are getting more efficient, VFDs and so on. And then the treatment of using membranes and different technologies to remove impurities, similar to kidneys, the liver. You look at the aeration systems, the lungs of the system. And then if you look at sensors, the sensors are starting to get really sophisticated. Acoustic sensors, you can hear leaks. Turbidity sensors, you can see the contaminants. Even the pH sensors, if you will, taste the acidity or the basicness of the water. The key component that's not really up to the design powers of these sophisticated systems is really the brain of the system. And so that everything works in conjunction and feed forward feedback loops. And I look at it as water really needs this step up in terms of computational fluid dynamic modeling, digital twins where you can actually look at the system and make some changes to parameters without actually changing the system, but knowing what's going to happen and how it works. Collecting data. Data management is crucial to operating a well-performing water treatment system. So water treatment really needs technology to step up so that it can be more efficient, more cost effective, and do a better job of treating both drinking water and wastewater.
Yeah, rightly said, Jim. So as you mentioned that the cost effectiveness and the operations benefits. So do you have any suggestions for small and mid-sized utilities? So I read your article. So you have mentioned about digital twins. So you have any suggestion on the digital transformation front on for these utilities, particularly water utilities?
Sure. Sure. One of the things I can talk about is the way Maisie's involved in it.
Yeah.
And our technology does a good job of mixing and contacting, especially gas, into the water stream. And if you think about these sensors, they only are going to be as good as what they report, right? So what Maisie technology does is it does a really good job of creating a homogeneous mixture so that the sensors see what's actually at the water. So let's say for an ozone system, if you don't have good mixing of that ozone and the sensor doesn't see what's actually in the water throughout the water in a homogeneous mixture, then it might sense that there's not enough ozone and go back and have the generator create more ozone when it doesn't really have to. Then on the other side, if there's not enough ozone in there and the sensor is seeing that there's a high concentration of ozone, it's not going to tell the system to increase the amount of ozone, and it's not going to do the effective disinfection or treatment of organics in a water reuse application. So it's really important that these sensors see, they're great and they can tell what's going on, but if it's not a homogeneous mixture and it's not seeing what's really in the water, then it's being defeated. And so that's one of the things that Maisie's really bringing to the table as far as our technology.
So any one-liner suggestion, as we earlier talked about, any one-liner suggestion for this utility
Say
edge?
just make sure that your whatever sensors you have are seeing what's actually in the water and making sure that you have a homogeneous mixture going through the pipes so that you have that good relationship between what you're trying to put in the water and what's actually there.
Yes. So thank you so much, Jing, for giving us an opportunity to interact with you. Indeed, it was great to have you on the Utility Cloud Guide series. Your thoughts on the technology and water as two sides of a coin will definitely help the water industry.
Thank you so much, Umang. I really appreciate the opportunity.
Thank you. Thank you to our audience also for watching our show.